Hello world! Welcome back to this tutorial on building a Linux from scratch system. In the last video we have built all the packages from chapter 8 up to and including Vim. And now I want to finish chapter 8 and then go through the system configuration in chapter 9. So let's jump right back in by creating the script files. Okay. Okay, now let's double check the download locations, because I started building this with the System V version of the Linux from Scratch book, and so these last packages might not be in there in my packages CSV. Okay, System D and dbus seem to be the only ones that I needed to add. Alright, then let us run the installation for these. Okay, mount the drive again, and I will also mount the boot drive. Might need it later. Okay, second try. It says here it couldn't unpack the documentation of system D. Yeah, the documentation isn't really necessary, so this might not be critical. I will just let it run anyways. Well, this log file looks terrible. It's much too short and it only says that it couldn't find things. So yeah, I think I will have to download the man pages and yeah, I will just put them in the packages CSV. All right, now let's run this again. Okay, now everything has run through again, and I've already looked into the log files, and yeah, this looks much better here. See, it says it's installing this and that, and here this this build process here where you have these 1833 parts and they are compiled one after the other, so yeah, that looks much better. Okay, so let's continue with chapter 9. Yeah, in the system V videos we would have configured system V and gone through these boot scripts, but in system D you don't have these boot scripts because yeah, system D has more of a wholesome concept behind it. So you don't have to give it all the scripts for it to know what it's supposed to do. It already has some idea of what it is supposed to do. So you don't have to write your own network scripts and stuff. You just tell systemd, hey, do this with a network, and systemd will do that. And it's not that much our problem. Okay. So, now that we are through with chapter 8, I think it's appropriate to have another script. I should come up with more creative names here, but okay. Okay, I prefer setting my own names for the network devices. This here would, I think, use a default way of naming things. Okay. Okay, I need to put a MAC address here. So using IP space A, I've printed this list of my current network settings, and yeah, this is my MAC address for the wired Ethernet port, so that's why I put that there. Okay, I could configure the network with a static address, but yeah, I personally think that using DHCP is a better way of at least doing things out of the box. Because I mean, everybody has a DHCP server in their home router today, so we need to set the name for the network device that we are using here, and that's the one we've set here, so either 0. We'll be using IPv4. Let's not use domains. Okay, systemd even creates its own resolve conf, which is a list of DNS servers, and yeah, for compatibility reasons, it's a good idea to make a symlink to that generated file and put that where other programs might be looking for it under etc resolve conf. Yeah, the entries in there should be taken from the DHCP server. Now let's set the host name. It's by putting the host name in a text file in etc named hostname. Okay, etc hosts is yeah, something like a local cache for DNS entries, but these days you wouldn't do much more than put in a 127.0.0.1 localhost here to tell it, well, if I'm talking to localhost, then I'm talking to myself. Yeah, for IPv6 also. Chapter 9.3, Overview of Device and Module Handling. This was actually the most interesting part of the whole process for me, because I've always assumed that the kernel handled the dev directory. And yeah, as you can read in here, that's not true. The kernel handles the sys directory, and then there's a service named UDEF, which reads stuff from the sys directory, which is for communication with the kernel, and UDEF then creates all the device nodes in the dev directory. So then you can have configuration files for UDEF to manipulate. Like you could give the same device name to the same device all the time, because yeah, the thing is that depending on how fast a device answers in the boot sequence, things can just be renamed after a reboot. So you have device A, B, and then let's say two Ethernet devices, and sometimes you boot and A answers first to the request, hey, what devices do I have? Then A would be ETH0 and B would become ETH1. But in the configuration for UDEF, you'd be able to say, no, A should always be ETH0, B should always be ETH1, because otherwise it just could happen that next time you boot, B answers first, and then B will be ETH0 and A will be ETH1, and that would not be so nice. So you can change that with UDEF rules. But I have to say, I've been a bit stuck on this chapter here, because it explains several things of how to configure several things in UDEF, like how do you force something to be loaded, how you can prevent something from being loaded. But yeah, the reason why I was stuck was because I just didn't see what does that mean for me? What is it telling me to do? So what should I do? I mean, when I install a Linux system from a distribution, then I don't have to write my own UDEF rules, right? So yeah, in the end, I just decided to live with the problem that devices may be named differently in different reboots. So I'm basically just skipping this directory and doing nothing. Yeah, you see, that's what I mean. Here you could deal with having duplicate devices. Yeah. That's stuff for the configuration of UDEF. Okay, let's go into the configuration of the clock. And yeah, you have a few things here, things that you could set or not set, and how to set. I don't care much about this question. I just want to move forward. Yeah, having time synchronization, I think, is not a bad idea. So let's come to the console. So I could set the keyboard layout here, but yeah, I would have to look into the lists of models and variants and options. I will just accept having a wrong keyboard layout, like on my German keyboard, the Y and the Z will be flipped. So yeah, I'll just ignore that for now. Okay, now LC all the locales. So with locale-A, you can list your locales. DE underscore capital D capital E dot UTF-8. That's on my German system what I would use. That, for example, I think sets the currency symbol to a euro sign, and yeah, the decimal separator to a comma, stuff like that. Okay, now we have this input RC. Yeah, I think that's something that is executed at the system start to set several configurations for the terminal. Like it defines here the key code for the home key and the end key and the delete key, so that when you press a key, it actually happens what you expect to happen. Like when you press a backspace, you expect the last character to disappear and not some gibberish appear on the screen. Okay, now the etc shells file. That's again something relatively interesting. With this, I mean, every user can select his own shell. Like when he logs in, he wants to use a bash, or he could also use a regular Bourne shell. And you could also have other shells, like there's a C shell and a Z shell, and there's many more shells. But yeah, with etc shells you can limit which selections are legal for the user to say, I want this to be my shell. Because if the user says, hey, I want my shell to be bin false, then he cannot log into his account anymore, because every time he logs in, bin false immediately terminates again, so he wouldn't be able to log in anymore. And by not having bin false in here, you can prevent that problem. So this is basically an allow list of things that are allowed to be shells. Okay. Disabling screen clearing at boot time. The normal behavior for systemd is to clear the screen at the end of the boot sequence. If desired, this behavior may be changed by running the following command. Yeah, I think that's a good thing, because we are interested in the boot sequence, right? So I think it makes sense to keep some information about the boot on the screen and not remove it just because you are through with the boot sequence. By default, temp is created as a temp fs. If this is not desired, it can be overridden by executing the following command. I don't care, I'll leave it like that. Automatic file creation. Yeah, I don't see anything we need to create at the system start automatically, so let's skip that also. Okay, default behavior for system services. System services should always be restarted after 30 seconds. I think that's a good setting. I mean, if you compare that to systemv, yeah, the RC script would just start some system services, and if they crashed, well, systemv didn't care. So if you wanted things to restart, then you would have to write some script around these services that would take care of that. And yeah, I think that's not a good design from a user friendliness perspective. So I think systemd is much friendlier in that regard. Okay, but this would have to be set for each service individually, so I'll just comment it out but leave it in there. Okay, now it gives us some commands to look into kernel infos like journal control, which is a systemd version of dmesc or dmessage that we use to look into the ring buffer of the kernel. Yeah, core dumps. So if something crashes, you can limit the size of a core dump. Yeah, I think that's a good idea. We don't want to fill our hard drive. I think 1 GB should be enough. Maybe 640 kilobyte, 640K should be enough for anyone. Okay. Okay, that was all for chapter 9. Chapter 10 I want to do in the next video, so yeah, I think this should be all we need to do right now. Have I saved the file? Oh, wait a minute. I don't want to rebuild all this stuff. Okay. Okay, yeah, that doesn't look bad. So it set the link to the resolve conf. This here looks like it has something to do with the locales. Yeah. Okay, yeah, this all looks like it went through fine. So yeah, I think I'll leave it at that, and next time we will go into chapter 10, and yeah, that's gonna be really interesting. You definitely don't want to miss that. We will compile the kernel, we will install grub, and hopefully we will already be booting the kernel. So definitely don't miss that. It will be really interesting. So yeah, if you liked this video, like it, share it, subscribe, and see you next time.